Bismillahirrahmanirrahim. This is Umar Muawia from BS Chemistry Semester 6. Today topic of my presentation is Hydrothermal Synthesis Part C. Here in this lecture, the key concepts are new trends in solvothermal crystal growth processes, its examples and applications. We will study here in this lecture solvothermal process for growing large single crystals and the solvothermal process for crystal growth at nanoscale. There are two different domains in solvothermal process for growing large single crystals. First one is crystal growth for oxides and the second one is crystal growth for non-oxides. Here are some examples. Alpha quartz for its piezoelectric properties, and second one is aluminium phosphate, gallium phosphate and gallium arsenate. The properties are they are like alpha quartz and their properties are like piezoelectric materials. And the third one is calcite, calcium carbonate, and its optical properties are birefringence and the transmission over a wide spectral range. The fourth one is zinc oxide, and its properties are uh, this is wide band gap semiconductor. This is transparent and it contains dielectric and piezoelectric properties. Crystalline aluminum silicate containing pores and cavities of molecules used as sorbents, catalysts, ion exchange materials. In these pictures there are shown diamonds, quartz, piezoelectric crystals that are made by hydrothermal method. Now this is the second domain we are discussing in solvothermal process for growing large single crystals. This domain is crystal growth of non-oxides. During these last years, strong efforts have been made for controlling the solvothermal crystal growth of gallium nitride using a process derived from alpha quartz and zinc oxide solvothermal crystal growth. References are given here. Such efforts are supported by the existing or potential applications of gallium nitride. These applications are optoelectronics, high frequency, high power electronics, fast speed communication. Now moving toward the second topic we are studying in this lecture is the crystal growth of materials at nanoparticles. As the size is reduced to the nanometer range, the material exhibits specific properties due to quantization effects. In such a case, morphology plays an important role: 0D, 1D, and 2D. The solvothermal processes and the crystal growth at nanoscale. Recently, one-dimensional 1D nanostructures, wires, rods, tubes have been the focus of intensive research owing to their applications in mesoscopic physics and fabrication of nanoscale devices. The formation of a 1D, one-dimensional nanostructure depends upon two steps: the nucleation, the crystal growth. In addition, for generating nanostructures, three main parameters must be controlled: the dimensions, the morphology. The third one is monodispority. The schematic illustrations of different strategies for achieving 1D growth are here. In in figure in figure A, we can see the induction of one-dimensional morphology through the anisotropic structure. In figure B, we can see confinement by a liquid droplet in solid or liquid process. In figure C, use of templates, and in D, use of capping agents able to modify the growth. Use of capping agents able to modify the growth rate in one direction. In figure E, you can see the self-assembly of zero-dimensional nanostructure, and in F, the reduction of size of one-dimensional microstructure. And the reference. Characteristics of hydrothermal synthesis. Advantages of hydrothermal and solvothermal synthesis. The first one is most material can be soluble in proper solvent by heating and pressuring the system close to its critical point. The second one is synthesis. The second one is significant improvement in the chemical activity of the reactant, the possibility to replace the solid state synthesis, and the material which may not be obtained via solid state reaction may be prepared through solvothermal and hydrothermal synthesis. Third one is products of intermediate state, metastable state, and specific phase may be easily produced. Novel compounds of metastable state and the other specific condensed state may be synthesized. Number 4. Easy and precise control of the size, shape, distribution, crystallinity of the final product through adjusting the parameters such as reaction temperature, reaction time, solvent type, surfactant type, precursor type. Number 5. Substances which are low in melting points, high in vapor pressures, and tend to go pyrolysis will be obtained. Characteristics of hydrothermal synthesis. Disadvantages of hydrothermal and solvothermal synthesis. Number 1. The need of expensive autoclaves. Second, safety issues during the reaction process. Third, impossibility of observing the reaction. Now look at the applications of hydrothermal synthesis in the preparation of nanomaterials. Number 1. The hydrothermal process have made firstly proposed to stimulate the genetic condition of geological minerals. Number 2. Later it has been adopted in the synthesis of molecular sieves and the crystal growth. Number 3. Now with the different starting materials, solvents, reaction temperature, as well as other experimental parameters, people have reported the synthesis of various kinds of nanostructures through the hydrothermal and solvothermal approaches, including metal oxide, carbonaceous nanostructures, and applications of hydrothermal synthesis in the preparation of nanomaterials. Uh, Hydrothermal and solvothermal synthesis of zeolites, hydrothermal and solvothermal synthesis of metal oxide, hydrothermal and solvothermal synthesis of carbonaceous material, hydrothermal and solvothermal synthesis of nanowires, and the other strategies for hydrothermal and solvothermal synthesis. Conclusion. To open a routine through new soft chemical processes. Kinetically controlled for stabilizing metastable systems. To help synthesis of specific structures using templates. To control the nucleation crystal growth processes for the preparation of nanocrystallites well defined in size and morphology. To facilitate through the improvement of chemical reactivity and the development of mild temperature conditions, the synthesis of hybrid nanosystems, mass production of samples. All the objectives of solvothermal processes require to optimize the physiochemical properties of precursors, the physiochemical properties of the solvent, the thermodynamical parameters such as pressure and temperature. Solvothermal processes appear to be important in near future not only for developing basic science but also for developing new industrial processes in mild pressure and temperature conditions. Thank you.